am Pranav Chashra. I'm a Principal Product Manager at AWS, and I specifically focus on AWS Local Zones. With me, we have Rob Sarnicki, who is the Head of Product Management for Hybrid Cloud, and he focuses on Outposts amongst other services. I'm really excited to talk about delivering low latency applications at the edge, especially because I've seen the journey of launching Outposts and Local Zones in 2019, and since then we have brought a number of services and features to these offerings, and we've also extended these offerings to multiple locations across the globe. So before we start, I will walk you through the agenda today. So in this session today, we'll discuss different use cases where low latency matters, and then we'll dive into local zones and outposts and understand how we're enabling customers to serve low latency use cases in both metropolitan areas as well as on-premises using outposts and local zones. And then we'll discuss Riot Games' experience with local zones and outposts and how they're using both of these offerings to enable low latency applications at the edge for their gamers. And then finally, we'll end the session with Q&A for any questions that you have from the audience. So what are the specific use cases for which customers are using AWS Hybrid Edge offerings? We've seen a number of customers from different verticals and industries using hybrid services to unlock a variety of use cases. So in this continuum, we have enterprise migration use case on the left-hand side, which includes everything from the back office applications to the SaaS applications, where customers have been working to move these applications to the cloud. And what we've heard from customers is that given their interdependencies and their size and constraint, it can be daunting to move these applications to the cloud in one go. And then on the right-hand side, we have low latency use cases, which include things like real-time gaming, machine learning inference, and content streaming, and things like media content creation as well. And then finally, in the middle, you see use cases which require data to be in a particular location, either because of residency, regulatory, or local data processing needs. And what we've heard from customers is that when it comes to all the use cases that I spoke about in the previous slide, what customers want is a consistent experience that they're used to in regions. So what it means is that they want the same APIs and services, same tools for automation, things like security controls, and the other operational things. The expectation there is that they should have the same experience that they're used to in regions today. And with this consistent experience across regions and edge environments, what we've seen is that customers are not only able to accelerate their innovation, but they're also able to manage their global deployments using the same skills and the tool sets that they're used to. So now that we understood the overall spectrum of use cases where hybrid services are being used today, I'm going to dive deep into low latency use cases specifically and understand how various AWS Edge offerings are unlocking these low latency use cases today. So to get more context, in the next few slides, I'm going to walk you through what low latency means for different verticals and industries. The first important low latency use case is the real-time multiplayer gaming use case, where companies like Riot, Epic, and Supercell, they deploy the game servers closer to the end user across the globe. And I'm a gamer myself, and when it comes to low latency gaming, if there is lag, if there is a different experience than what I see for the competitor, it of course increases my chance of dropping from the game. And that's where the latency becomes key for these companies like Riot and Supercell. So depending on the game, latency of 20 to 40 milliseconds is considered ideal for good gameplay experience. And given their low latency requirements, these customers tend to deploy their applications across multiple locations so that they can be closer to their gamers across the globe. So next, we have media and entertainment use cases where customers like Netflix, who are creating beautiful content for us, they have these expensive artist workstations in specific metro areas where they have animation hubs like Los Angeles. And they tend to use these workstations for things like video editing and live production. And for these artist workstations, again, latency again becomes very important to have a jitter-free experience for these artists. And specifically talking about the latency here, these customers have, in fact, even lower latency requirements. They need less than 5 millisecond latency from their animation hubs and offices where the artists are to where these virtual workstations are running, so that artists can create the beautiful content that we used to without really going through any jittery experience. So next, we're going to discuss a completely different vertical of financial services, where we have customers like NASDAQ who run financial exchanges in places like New York. And considering their real-time data needs and their distribution needs, these customers again have requirement for ultra-low latency to the compute, where they're running things like real-time risk analytics and market analytics for trading data. And it's not just financial industries. We have customers from the healthcare as well who have requirement for low latency compute. These customers rely on various management softwares to empower things like radiology, health systems, and clinical research. And when it comes to these use cases, these customers need, again, rapid low latency access to the high quality images for things like radiology, so that their radiologists can focus on improving the patient outcomes without really worrying about these healthcare systems. And then finally, another great example is the enterprise migration use case, where, as I said, there are enterprises across the globe who are running their workstations or their different workloads on premises in their data centers. And many of these customers told us that it can be daunting to migrate portfolio of interdependent applications to the cloud in one go. And as a result, many of these customers tend to like the hybrid environment, which provides ultra-low latency communication between their on-prem as well as where they're running their workloads on the cloud, so they can migrate their applications incrementally without really drastically changing or refactoring their applications. So now that we have discussed different use cases for low latency, how are we really serving these customers on AWS today? And what we're doing here is basically we're bringing AWS to wherever our customers need it. So on the left-hand side, we have AWS regions, which are available in 32 locations, and they tend to meet the latency needs for majority of the customers. And then we have local zones and wavelength that are in particular specific metro areas, which basically allow customers to have the benefits of compute and storage closer to their end users and their own on-premises without the need to operate their own data centers. And then we have AWS Outposts, which is basically meant for customers who need to manage their workloads on premises. Outposts basically extend AWS infrastructure to virtually any place that you can think of, things like data center, on-premise facilities, for a truly consistent experience that customers are used to in region. And then we have Snow Family and IoT, which I won't be covering in the session. We have other speakers who are going to talk about it a bit more in the next few sessions. So in this section, we'll talk about low latency use case and specifically focus on metro areas and telco networks, where I'm going to talk about how local zones allow us to bring cloud closer to more customers and end users and allow us to meet these low latency use cases in metropolitan areas. So before I dive deep into local zones, I think let's first understand what they really are. Logically, you can think of local zones as very similar to availability zones. It's just that they lie in a different physical geography. So what we've done here is we built data centers in particular metro areas where AWS deploy and manage the infrastructure in these large metropolitan areas. And these local zones are connected back to the parent region using multiple redundant high-speed links, so that customers can continue to leverage the services that they're used to in regions as well. Similar to regions, local zones also provide the consistent on-demand elastic experience that customers are used to with the pay-as-you-go pricing. And then you get the same AWS security, core services, and developer experience in local zones. So now that you've understood what local zones are, I think the logical question, of course, is why did we really launch them? And the answer sort of lies in developer expectations. If we look at this visual cue here, let's say I'm a gamer who is in the Houston metro area, and I'm playing a game. Previously, when we launched local zones, before that we had 4 regions in the US. So if I'm in Houston, the nearest region for me is the North Virginia region, which is, of course, more than 10 milliseconds away from Houston metro area. What it means is that for majority of the end users across the US, like me, who are playing these games, if they're using these regions for their gaming sessions, they get over tens of milliseconds of latency across the contiguous US. And then what we did here was we basically launched Houston local zones, which brought compute closer to end users like me, which means that now I can access the gaming session with single-digit millisecond latency which allows me to basically have the consistent and real-time experience that the expectation is from the end users. So where do we have these local zones beyond Houston? So if you focus on the US here, we started launching local zones in 2019. Our first local zone was in Los Angeles area. And then since then, we have expanded our presence to 16 more metros. And the intention here is to provide single-digit millisecond latency experience to users across the contiguous US. And we're not stopping here. Building on the success we had in the US, we are also launching local zones internationally. So 2 years back, we started launching local zones globally. And as of now, we have 17 local zones available in various metropolitan areas outside the US. This includes places like Auckland, Bangkok, Lima, Manila, San Diego, Taipei, and others that you see in yellow color here. And then we've also announced 15 more local zones in many more countries and metros, which include places like Colombia, Greece, and Netherlands, which basically, again, would enable customers across the globe to provide low latency experience to their end users and on-premises. So now that you've understood why we launched local zones and where they are available, a key construct of local zones is, of course, what services are available in these local zones. So when we launched these local zones, we started focusing on bringing services where latency matters. So we brought core compute services like Amazon EC2 for compute, Amazon EBS for block storage, ECS and EKS for containers, and then things like Amazon VPC, Route 53 geo-proximity routing, AWS Shield and Direct Connect for the consistent networking and connectivity experience that customers are used to today. And then the ones that you see in the gray here, these are some additional services that we've added based on the feedback from customers in specific industry hubs and metros. So we have FSX, RDS, EMR, Elastic Cache, and application load balancer available in certain metros. And the intention here is to keep bringing more services to more locations depending on the use cases that we see in those metros. So we just discussed that local zones is a logical extension of regions, and that is also reflected in the pricing here. So if you're using local zones, there is no fees for enabling local zones. EC2 instances in local zones have on-demand pricing, and you can also purchase savings plans to get the benefits of longer-term commitments with the discounts. And then instances in other AWS resources running in local zones have their own prices, and they vary across locations, how it usually works for regions as well. And then when it comes to data transfer, the data transfer prices are very similar to how it works in AZ. So if you have an EC2 in the local zone and sending traffic to S3 back in the parent region, the data transfer is free of cost, just like how you're able to access S3 back in the region from AZs without paying any data transfer charges. And then beyond on-demand and savings plans, we also have spot pricing available in certain metros, and we continue to expand that presence more globally as well. So we have discussed what local zones are, why we launched them, where they're available, and their pricing model. Let's sort of understand how local zones work in practice. So to get started, you just need to enable local zones for your account, and you can do that from the console and API. When you enable your local zone, you can extend the VPC from the parent region to the local zone by creating a subnet and linking it to the local zone. And then you can start launching resources like Amazon EC2 and others in that subnet and start building your applications to meet these low latency needs. So this architecture is a good representation of what we discussed in the previous slide. Here you will see the VPC in the US West Oregon region, which is extended to the local zone in Seattle. And what we've done here is basically create a subnet, linked it to the Seattle local zone, and the VPC has been extended. And all the things like route tables and security groups have been taken care of. And the fact that local zones have their own connectivity to Direct Connect and to the internet gateway, it allows you to meet your low latency need for both end users and on-premises facilities. In addition, I discussed earlier that local zones are connected back to the parent region using redundant high-speed backbone connections, which means that you can use things like Amazon S3 and RDS back in the parent region, just like how you use it for AZs today. So in the beginning of the presentation, I discussed examples where latency matters. Now that you understood local zones, I'm going to provide you a couple of examples where local zones are solving these business problems and the impact we've been able to create with them as well. The first good example is the Netflix use case here, where Netflix have been thinking about moving their workloads from their animation hubs in places like Los Angeles to the cloud. where they were running artist workstations. And when it comes to these artist workstations for media and entertainment customers, latency is key to having a jitter-free experience. So what Netflix did here was they basically used iConnect to establish connectivity between the animation hub in LA to the local zones in LA as well, which allowed them to have low latency access to the compute, get less than 5 milliseconds of latency, and the artists were able to use these workloads on the cloud and run these virtual workstations for things like live production, video editing, without really thinking about how to scale their workstation and without really going through any jittery experience. Another great example is the MindBody example here, where MindBody was operating their own data centers in LA metro area. And what they told us was that it can be daunting to migrate portfolio of independent applications to the cloud. So what they did here was they also used iConnect to establish hybrid connectivity between their own data centers and on-premises and the local zones in LA metro area. And in turn, this enabled MindBody to establish a hybrid connectivity, which basically meant they could now move their applications incrementally without really refactoring their applications too much. So now that you've understood local zones and various business problems that we're solving, I'm going to hand it over to Rob, who will discuss how customers are using local outposts in addition to local zones to deliver these low latency application experience on-prem. Thanks, Rob.
Thanks, Pranav. Welcome, everyone. I'm Rob Zarnecki. I lead product management for many of our hybrid cloud services and spend a lot of time focused on outposts. So as Pranav described, we start in the region. We can extend out to local zones, which will always be available and online in more metro areas than we are able to build regions. Not that we're slowing down at the pace at which we build regions. But then we can go even farther out with AWS Outposts to bring them on-premise, to bring them to metros where the local zone isn't yet online because we need to extend our network border, or things like that. This is super, super useful for customers that have their own data centers, whether that's in a colo facility, whether it's in a manufacturing plant, maybe it's a telco edge site where there might never be a local zone close enough, or it has to be, the compute has to be adjacent to the customer's existing technology. So today we have the Outpost family, 2 different flavors, if you will. We have a 42U rack version and a 1 and 2U server version. The rack version is the very same rack that we use in our regions. We manage everything inside that rack. Think of it as the smallest AWS footprint you can bring. We roll it into your facility, connect it to network and power, and we manage everything inside. The servers, which are even smaller, can extend, they could be in a data center, and they could be co-located in a rack with technology that you already have, or they could be outside of a data center, perhaps in a retail store, in a back management office, in an IT closet. They're just going to plug into a regular outlet and allow you to bring that compute to places where a 42U rack wouldn't fit, or where you don't need 12 or 15 servers. You only need 1 or 2 or 3. Never deploy 1. 2 is always the best practice. Now, Outposts, much like local zones, they allow you to bring AWS to you, right? And as we built our hybrid services, we listened to so many customers, probably not unlike yourselves, who told us that the value of writing code and building applications using a consistent set of APIs, tools, and services was huge. That means there's no need for their developers to be versed and trained and certified and fluent in 2 different sets of tooling, one for the cloud and one for on-prem. So with AWS, you're going to write code and you're going to build your applications using that same set of tools, and you can deploy them anywhere. The other thing that customers shared was that they didn't want to manage the infrastructure. As we've been saying for years, that's undifferentiated heavy lifting. So we're going to manage that for them. Of course, think about the shared responsibility model that we have in our AWS regions and local zones. That same model applies at the edge. The only difference is you as the customer or your colo partner, or anyone else for that matter, provides some physical space, power, and a network connection. But we'll manage the hardware, we'll replace it when necessary, and we manage it all using the same tools and systems that we use in the regions. We treat this as an extension of our regional fleet. And the other nice thing about it is we're going to give you a single pane of management, single pane to manage all this, right? So once you order your Outpost and you initiate those resources, your EC2 instances, you're going to see them as part of the regional console, so you can manage your fleet across its entirety, or you can narrow in, and you can use all the tools that we have, such as CloudWatch and CloudTrail and all the other monitoring and alarming services that we offer in region for your edge deployments. Now what this huge leap has allowed customers to do is to just simplify the complexity of managing their IT. It's allowed them to amplify their developer productivity. It's allowed, frankly, people on-prem to move at the pace of the cloud, and to bring that cloud-first approach to that mental model of designing and focusing your resources and your investment at the application level, where you're going to differentiate your businesses and the services that you provide, rather than needing to also spend resources and time and money and everything else managing the infrastructure that those applications sit on top of. So to go a little bit deeper on the Outpost rack, this was the first service that we launched, announced it back at reInvent in 2019. It's an industry standard 42U rack. This is not small, but fits in a standard position in most data centers. We build this at our manufacturing sites, and we bring it to you fully assembled. We plug it into the network. We send an advanced team out to make sure you have the right power port, to make sure that it can fit around the corners. The floor is rated. These things, when they're fully loaded, weigh about 1,700 pounds. So it's a non-trivial delivery. We bring it in a wooden crate with tamper-resistant sensors to make sure that everything has been safe and secure through its entirety of its journey. We plug it in. We offer redundancy across the board here. Everything other than the compute servers, which you choose yourself, there's at least 2 of. We have redundant power, as power is one of the most common failures in compute racks. We have redundant networking switches. We have redundant networking connections, and we're constantly monitoring and managing everything inside this rack to make sure that it is online for you. You can see right here a little picture of the 5 to 15 kVA power supplies that we provide 2 of. We recommend you connect these to different sources. So whether that's a generator and 1 feed, some facilities have 2 independent feeds that don't have a single point of failure. That's going to increase the resiliency of your system to failures. The same point for network. We recommend 2 different network connections with independent paths, so they don't just reconverge on the same piece of fiber 10 miles down the road, which is subject to a storm, a backhoe, any of those host of things that can disrupt network connectivity. And with the compute, you choose how much compute you put in this rack and what types of compute you put in this rack. Again, we recommend extra, and we can partner with you to strike the balance between how much compute you need, how much space and power you have, and tailor the resiliency of this outpost for your specific needs and your budget. When you think about how that looks logically as an extension of the region, it's very similar to the picture that Pranav showed about the local zones. You just extend your VPC. For those of you that are deeper into the networking space, the Outpost resources will show up as a private subnet available only to your AWS organization within the region that you connect it home to. So that these are managed by the regional control plane, much the same way local zones are built. And you can have a VPC that includes resources in multiple availability zones within that region, maybe even within a local zone that's connected to that region, and within the Outpost. Now what the Outpost brings to you is 2 new logical networking constructs. One is called the local gateway, and that's a connection to your local network. Whatever's in your data center, that could be the internet, it could be other technology. And there's also another logical network construct called the service link, and that's our connection back to the home region, the heartbeat, if you will, where we're pushing your AMIs across and sending metadata back and forth to monitor the health of the system. So you will see us using a little bit of traffic on your network, and that's just us monitoring the hardware. Services, again, we mentioned using the same tools is a huge part of the value proposition here. So we've got about a dozen services that run locally on the Outpost. Of course, the Outpost resources can use services back in the region. You need to be mindful of what is the reason that you're using the Outpost. Is it data residency, and does some of that data have to stay on the Outpost? Is it latency, and can there be workloads that are not within the critical path that could use something like Lambda back in the region? We have our core compute services. We have our elastic block storage. We have containers, both Amazon Elastic Container Service and Elastic Kubernetes Service. We have a local resolver from Route 53, local object storage from S3, load balancers, databases, analytics with EMR. And we're constantly looking at what we can do to better serve customers and make that experience the same. One of the important things that we look at here is partners as well. for two reasons. One, we have a huge swath of Amazon Partner Network partners who are building solutions that are API compatible with AWS services, which means that satisfies our tenet of a customer being able to write an application and run it at the edge or in the region, even if the underlying service at the edge might be provided by a partner instead of by AWS. The other thing that we look at is customers are also migrating from workloads that are running on what we call commodity hardware on-prem, and they're using many of these partner solutions. So if the partner solution that is already built into their application that they're familiar with can come across to that edge device, that just accelerates the migration and takes some potential friction out of the way there. Now, Outpost servers, a little newer than racks. Super excited about this space in particular. We've just been at this with the servers for a couple of years. These are going to fit into a standard 19-inch rack. We have a 2U server that's built on an Intel processor, and that small 1U server is actually built on a Graviton processor. This is the first time you can run Graviton workloads outside of our data centers. And what customers are starting to do with those is super exciting. And stay tuned for more news on that. They don't require nearly as much power as the racks. They support a 10 gig uplink speed. You can run 1 gig if you prefer. Rather than that local gateway that I talked about on the racks, we use a layer 2 network interface here, and we call it the local network interface, or the LNI. So a slightly different network topology, and that's just because this is one server. In the rack, we're managing multiple switches, and we're able to present that in a slightly different fashion on your network. Servers, how they work, very similar to the racks, right? Just an EC2 instance, private subnet within the home region. You can have a VPC that spans multiple zones, include your Outpost server, include your Outpost rack. You can design this and configure it however it works for you. There's no wrong way to do it. The key part of it is this works just like the region. This is just another EC2 instance. And that was a very deliberate design choice that we made as we built the service. You're going to communicate directly with those resources from your local network across that LNI, or the local network interface. We are still going to have a service link connection, that logical heartbeat home to the region. And you're able to spin up compute resources and access those locally, whether you're running control systems in a factory or elements of a smart retail store or any other use case. We certainly have plenty of people, both AWS employees and customers, running these things in their basements and in their home workshops, just experimenting. And I think that's a great signal of the momentum that we're building with the server business and how easy it is to get these things out there and bring EC2 to the edge. In terms of availability, we can deliver an Outpost, either a rack or a server, in 76 countries and territories today. I know there are a few more than 76 countries and territories in the world, more to come. The way we think about this is there were what I'll call them the easiest set of countries where we've been doing business for some time. There was a mid-band set where it's really just a matter of us having the correct registrations to do business, bank accounts, approvals, et cetera. And now there's a longer tail of countries where sometimes it takes a little bit of time to get in front of the right folks and introduce them to us as a company and our business and obtain all the right certifications. If there is a country where you need to use EC2, you'd like to have an Outpost that is not on this list, let us know. Reach out to your account team. Reach out directly to me or Pranav or any of us this week. We're happy to prioritize. The rest of the world, quite literally, is just a prioritization exercise, and we're going to continue taking feedback from customers as we do that. A couple of customer examples. Pranav mentioned this earlier, but NASDAQ are now running 3 domestic exchange markets on Outposts based in a data center in the New York metro area. This is a super exciting development. We had the CEO of NASDAQ, Adena Friedman, on stage back in 2021 announcing a multi-year partnership with AWS. It's been a fantastic partnership. In December 2022, they announced the completion of their first migration. Missed reInvent by just a couple of days, unfortunately, but that was a big win within 12 months from us beginning the partnership to running one exchange. And just 2 weeks ago, NASDAQ announced that they had successfully migrated their 3rd exchange, and that's processing about 12 billion messages daily with extremely low latency and all the fairness and other regulatory conditions that are required to run an exchange in the US. Another quite different use case, but just as interesting, Mercado Libre. They're the largest online commerce and payments provider in Latin America. The business has just grown really, really quickly. And now they span 18 countries across LATAM and have more than 100 million active users. Now, as they've grown at that pace, they've really dug into their operational technology workloads with a forward-looking approach on how can we build for the future and how can we build for scale, which are great things to think about when you're growing at that clip. They've partnered with us and deployed a number of these OT workloads on Outposts, things like automation systems in their facilities, Wi-Fi access point controls, physical access, badge systems, and other things that are used to protect their supplies and separate folks. Many of these are running on Outpost racks. They're now starting to deploy Outpost servers in some smaller facilities for some other workloads that might work just as well and provide even more flexibility on the servers. And Outposts are really giving Mercado Libre the ability to run their applications seamlessly and modify or manage with a single pane of glass across all of Latin America and wherever else they extend beyond that, which is super exciting. And tying it back to gaming, Riot Games was one of the first customers that we spoke publicly about as we built the Outpost business back in 2020. I had the good fortune to be personally involved with our work with Riot through the heart of the pandemic, and they've just been a phenomenal customer and partner. Riot has selected AWS as their official cloud services provider. To give you a little bit of background on Riot, their mission statement is that they aspire to be the most player-focused game company in the world. They want to put the players at the heart of every decision that they make and the player experience. And their relentless focus on that is so, so clear. Three of Riot's most popular titles are League of Legends, which is a multiplayer online battle arena game. They have a game called Valorant, which launched in 2020. That's a 5-on-5, very tactical first-person shooter experience. And then they have another game called League of Legends Wild Rift, which is a mobile version of League of Legends, which is has a longer history, built from the ground up to optimize for that mobile game player experience. I want to talk a little bit about Valorant because that was where we first partnered with Riot to deploy Outposts. Riot focused so deeply on that character-based first-person shooter experience. They currently have more than 14 million active Valorant players worldwide and a number of agents and game modes to change the experience. As Riot built Valorant, they were very clear on their tenets. They wanted to ensure the matches were fair. With 5-on-5, which is different from some other games like Fortnite, which have 100 people in there. Fairness mattered. They wanted to support a wide range of PCs and to ensure that every customer's experience was smooth and responsive and rewarding. They really wanted to raise the bar on the defensive aspect of the game as opposed to the offensive aspect of the game. So they introduced something called Peeker's Advantage in Valorant. And this was really to their goal of giving that defensive advantage in the game over an attacker. The folks at Riot really knew they needed to solve the problem of not setting it up such that the defensive player exposed themselves to an attacker and leveled the playing field in event. So if you look at this animation as it runs through, there's a moment in time where that defensive player who were looking over their shoulder, if you will, can see the attacker before they expose themselves. That gives them a chance to act first and not always be in a position of responding. To simplify it a little bit with this animation and illustrate the problem, we need to sort of break down that there's a fundamental unfairness in the reaction time here. Now, one of the ways that Riot focused on resolving this issue is by focusing on a very low latency for the game player experience. As you can see in these visuals here, as the latency reduces, the impact of the Peeker's Advantage also reduces. And that's because the messaging between the player's PC and the server happens faster and faster. So Riot did a tremendous amount of research, and they determined that with a combination of a high frame rate, or what they call a high tick, their target was 128 hertz, that a client should be able to run that on most gaming machines. And they also wanted to target a latency target of 35 milliseconds. And their hypothesis was that they could reduce the peaker's advantage to a level where it was minimally impactful for gameplay and create a tactical shooter experience that they were looking for. So they set 2 targets for themselves, that 70% of Valorant players could reach a server location that is 35 milliseconds or less away, and that 90% of players would be 50 milliseconds or less away. You can see where I'm going with this, given this is an edge conversation, right? The latency target was a lot more ambitious than the targets they'd had for League of Legends, where they were open to tolerating farther latency. And the only way that Riot was going to hit that was by finding a way to bring their game servers closer to the players that were playing those games and optimize the routing as much as they possibly could. I'm pleased to say that Riot was able to do both using our edge services. They first knew that launching the Valorant game on AWS was the way that they wanted to go. So they first looked across the AWS regions and determined where could they run their game servers, and how did those latency maps cover the players that they were using. This was a fairly obvious place to start. And of course, back in 2019, there were probably a couple fewer options than there are today. The second choice after a region was, of course, a local zone, because it's so similar to a region for Riot. For all intents and purposes, it works the same. And since all the game servers are running the same software and all the services that the Valorant game server is built on are present in the local zone, it was very easy to also extend to the local zones and further optimize that latency towards their desired target. But the real thing that helped Riot hit their target was Outposts. Now, this was the third choice, right? They weren't going to deploy an outpost where they could use a region or a local zone, which makes great sense, because they had to carry some additional overhead. They had to have a data center. They had to manage the capacity. But it did allow Riot to bring game servers to locations that had no AWS presence and serve gamers that couldn't possibly get within their desired latency target using just regions and local zones alone. And if you take a look at the map here, just focusing on the US, when they started building Valorant, Riot also had a bare metal data center in Chicago. They were running in US East 1, US West 1, and US West 2. Now, if you think about where that is, the latency across the US alone is, there's no way that's going to be fair, right? There are places all over the country that will be quite a distance from those data centers. So they came in and they put Outposts online in Texas and in Atlanta. And the reason was they were focused on gamers in Florida and Texas. And if you look at the map right here, certainly not within the 35 millisecond target, but many of them can't even satisfy the 50 millisecond target. But when you overlay the Outposts in Dallas and Atlanta, both of those pockets of gamers are now well inside the 35 millisecond target, even with some suboptimal network routing. So Riot was able to achieve their goal by putting Outposts in those places. Now, of course, since then, local zones have come online in more and more metro areas, and Riot's been able to shift their workloads as appropriate and when appropriate. Just to show a little bit of additional color here, here's some data from Riot's telemetry pipeline. And if you look at what North America looked like, and then in Europe, they also brought Outposts online in Madrid and Warsaw. Let me go back. The latency and the segment of customers that were under 35 milliseconds increased by a meaningful clip, both in the US and in Europe. Now the next part, once we brought all this capacity online for Riot, is Riot needed to make sure they could route the network traffic efficiently. And Riot had been building their own network, which they call Riot Direct, since back in 2014. Just based on the size of their operation and the popularity of League of Legends. They wanted to help manage performance issues that had plagued players for years. And their hypothesis was that if we remove inefficient routing, via third parties wherever possible and just directly peer with as many internet service providers as they could, that would lead to a better game experience. There are a number of paths that customer packets can take to get from an ISP to a data center that's just connected to a single provider. And that's also exposed to other transient events like a DDoS or something similar that might not be targeted at Riot's network, might be targeted at another customer, but still has impact. And the goal here was to ensure that Riot players are on a direct path or the closest thing that they can achieve between their PC and their game server. So Riot Direct now spans the entire globe. It connects Riot players to Riot game servers and also Riot Studio locations where the artists are building these games to AWS regions, local zones, and outposts where they have them deployed. So that's our deep dive on Riot and their edge use case. Back to Pranav to close it out. Yeah.
So that was a great example of how Riot is leveraging the continuum of AWS offerings wherever they need it. So before we conclude, I'll walk you through a few more topics that apply to both local zones and outposts. And the first one, which Rob touched upon, is a common question that we get from customers is, how can I run these partner solutions on local zones and outposts? And the answer is similar to regions. You can find, buy, and deploy software solutions for local zones and outposts from the AWS Marketplace. So you see the slide that applies to the broader AWS Marketplace on AWS, and you see these popular 8 categories of software which are available across things like data products and professional services. These include softwares from key ISVs such as F5, Nginx, Couchbase, and more. And what we are seeing on the edge side is that we continue to see more customers who are leveraging more marketplace solutions to build their low latency applications here. So now that you've understood both outposts and local zones, of course the logical question is, how do you choose the right infrastructure for your applications? And the answer again is very similar to how Riot approached it. It really depends on 2 factors: where do you want to run your infrastructure and your network latency needs here. So if there is a region available closer to where you want to run your infrastructure, of course region is the right choice here, given it provides the breadth of services. And when there is no region available closer to your end users or your on-premises, but there is a local zone that can meet your latency needs, you should go ahead with local zones there. And then finally, if you have ultra-low latency needs that cannot be met by regions or local zones which are available nearby, then Outpost is, of course, the right solution for you. This, again, as I said, it aligns with how Riot approached it, and they were able to build their applications across the globe using regions, Outposts, and local zones. With that, we are into our session. Thank you all for coming to the session today. As always, we're listening to your feedback, and we will continue working on bringing more services and features to these offerings, as well as bringing them to more locations as well. If you like this session and want to learn more about delivering low latency applications at the edge, we do recommend you to check out both Chalk Talk and Workshop, which will get into more nuances and details of how it works in practice. Thanks again for joining us. We are going to use the next 10 minutes for any Q&A that you have. If you have any questions, I do recommend you to come closer to the mic, and then I can repeat if the question is not clear. Again, don't forget to complete the session survey after this session.